Hello students, today we'll discuss about decision tree, one of the classification algorithm used in big data analytics. So whenever we have lots of data available into the database or data set, then that particular data is not just to store for future usage, but we have to apply some of the very interesting and output generatable algorithms for gather or for generate a meaningful data out of it. So whenever we say classification, then the classification always have two different stages for the final implementation. So these stages are the two. This is also known as a two-step process. So the first step is model construction. So describing a set of predetermined classes. So whenever we talk about a classification, we used to have some classes already defined. The classes are defined on the basis of the features related to the data. So according to those features, we'll already define the classes like class A, class B, class C, or if we talk about the animals, then according to that we can have a pet animal and wild animals. So these are some of the predefined classes depending on the features we used to have for the classification. And these classes are constructed on the training set, because we used to have a different training set, different data for different classification. So if we have the data set, training data set, that training data set is provided to the module. So this particular module is nothing but a well-defined algorithm. So this particular algorithm is able to gather input the data and is able to classify to some particular class. So that is why this particular model, or we will say it as algorithm, so this algorithm is very much competent to classify the unknown data as well. But before it starts classifying an unknown data, it has to be trained, and that training will be provided by training data. So we keep on providing a training data, and we used to tell the model that this particular features are used to classify in a particular class. So this is this is how we create a model, an intelligent model. So once we develop a class, then in the first stage, then in the second stage, this model will be used. As I already said, model is nothing but a specific algorithm, well-trained machine. So that well-trained machine is able to classify. In the first stage, we construct a model. In second stage, we use that model for classifying unknown objects. So once once the model is available, then this model is able to classify the unknown object into a particular class. So for that, in the second stage, we will provide or will apply unknown objects or unknown entities to that particular class, and the particular model will be able to classify it accordingly. So this is a model construction stage. So in this model construction stage, we used to have the classifier. So this is a classification algorithm. So we use for constructing a classifier or a model. So for this classification algorithm, we provide a training data. So this training data is here as a table known or provided as an example. So it has different features like name, rank, etc. And with this data, classes can be created, and these classes will be known to the algorithm, and according to that, it will be able to generate the particular rules. So these rules are something like if rank is equal to professor, then according to that, the classes or the model is able to define a particular class for a known data first, and then for unknown data. So evaluating a classification methods. So when we say that there is a classifier available or the classifier is constructed, then some features or some characteristics should have for so that the classifier, we say that the classifier is good or best. So the characteristics what a classifier model used to have are the accuracy. So the classifier should be good enough for providing a better classification, or the result generated by classifying the unknown data should be very much closer, or we say that it should be accurate. The speed, the speed is required, either one for constructing a data and second for classifying the unknown data. So the time or the speed required for construction of the model and classification should be done in a small amount of time. So then we should have a robustness. It should be able to handle some missing values or noisy data. What is the capability of that algorithm? It makes it more competent. Then the scalability. It should be able to have a different data should be able to handle. Then there are many more different features available for saying or for defining that classifier as a good classifier. Then this is one of the classifier we are going to learn. It's known as decision tree algorithm, and this decision tree algorithm will provide you the behavior or how does it work. So in this decision tree algorithm, a tree is constructed like this from the training data. So this training data, we have a TID, refund, marital status, and so many different attributes for data. So these particular features, or we'll say attributes, are used for constructing a tree. So we have used the every attribute or the feature for making a decision. So the decision for a refund is either yes or no, because yes and no are the data available for this particular feature. So this can make two decisions, either yes or no, and according to that we have to go in two different paths for decision making. So accordingly we have marital status and then the taxable income. Every field has multiple decision making locations, multiple decision making branches. So that is why we say this particular the algorithm is a decision tree. Then these features are used for making the decision as and when required, so that yes is one of the factor and no is another factor, so that depending on that a decision tree is made. Then we have another example for decision making tree with the same data set. So this data set we used to have can be used for constructing multiple trees. Why multiple trees? Because the data can be used by every individual by his own idea with which a decision tree can be constructed. So we can directly conclude that the decision tree can be multiple on a single data set. But this is not the perfect way that we should go with, because every algorithm, every decision tree cannot generate the same result or cannot have the better performance. So with this we can say that the decision tree should be made so perfect that it should have all the characteristics for the algorithm which we have already studied. Then which decision tree is better? That is an important question, and with this question we will proceed for constructing a perfect decision tree as a classifier. So whenever we provide a data, so we used to have the data in two parts. One is training data, second is test data. The training data is used for constructing the model, and the test data is once the model is created, we used to verify it, check it the performance and the classification results of this particular model. Then the model is nothing but an algorithm, a tree induction algorithm, and we will be making this particular algorithm as a model known as a decision tree. Then this is a simple example with which we will be able to understand how the decision tree works. So this is the test data. Once we have constructed the model, a decision tree on a training data, unknown data is provided. We are supposed to find what to be done for this particular attribute. So we will apply the no status for a refund. This is unknown data. So this no status will make us to go in some particular path. So this particular path is followed because the refund contains our no. Then similarly, it will go for checking a marital status and then taxable income. So accordingly, it will go continuously for a further decision making step by step or to a particular branch. And finally, according to that, it will generate the data for this. So I can discuss one of the example that sometimes we used to have, or we used to make a timetable, something like a cricket timetable. So if we are supposed to create or construct a table, a schedule, we'll say this as a schedule. So cricket tournament schedule can be constructed, and this tournament is going to happen next year or after 2 years. So if we are going to construct a cricket schedule, then that schedule may have different possibilities, whether the match can be played on in some country and to a particular location, like in Eden Garden at Calcutta. So we used to get some history of that particular location, what is the rainy season in that particular region, and what will be the probable condition on that particular scheduled date, whether the rain is going to be there or not. Depending on that, the schedule will be constructed. So for this particular decision making, we used to have the algorithm, and these algorithms help us for creating a particular generating a decisions. So this is a decision tree classifier. What we are talking about, the training set has been provided with the induction, and this particular model has been created, and that will be provided for a test data. Then what is these algorithms? We have number of decision tree algorithm invented by many people, and some of those are here. The Hunt's algorithm, which is quite designed very early stage, and then we have CRT algorithm, then ID3, C4.5, and so many are there. But today we will be looking few of them or one of them. So we'll start understanding how a particular algorithm can be constructed. A decision tree induction algorithm, for designing any algorithm, we used to think about, or we used to understand how the training data set or how a basic data set will be. So this is an example. So this example says we have different attributes like age, income, student, then credit rating, bias, so buys computer or not. So this is a data set of a computer shop, which is able to decide whether a person is going to buy a computer or not. For that particular thing, decision making has to be done. The age is either the age is more than 30, or the age is in between 31 to 40, or it is more than 40, or it is either equal to in between 31 to 40, something like this. The income groups are different: high income group, then medium, then low income group. These are the three different conditions available with this particular attribute. Whether that particular person is a student or not, sometimes this is yes and sometimes this is no. Credit rating, so we have fair, excellent, and we have poor as well, but this is not defined here. Buys computer or not. So this is a decision making what we are expecting. Sometimes we say this as a no and sometimes as a yes. So this is a previous data, a history with which we will be able to construct a particular model. And let's say that this is a particular decision, or this is a particular decision tree module constructed. So it starts from a age. Age is the attribute. So we have three different classes available here. The age is greater than or equal to 30. The age is in between 31 to 40, and age is more than 40. Whether it is a student or not, and this particular is going to say that whether this particular person with the age group 31 to 40, whether he buys computer or not. So this green label is related with the he buys or not, and in case of yes, then this is defined here. So we have credit rating. If it is excellent and fair, depending on that he will buy a computer or not is going to be decided. So this particular model is constructed, but whether this is the perfect model or not, we are supposed to understand. This attribute age is defined at the start, and this yes and no is the final decision what we are expecting, whether this particular person is going to buy a computer or not. This kind of example can also be defined in the insurance industry or insurance organization. Whether a person is going to purchase a insurance policy or not, that should be decided. Then only a person who is going to approach to the customer, the decision should be made before that. So for that, the company will collect many different historical data set and will understand that which particular age group can make a decision to buy a insurance policy, and then only the executives will approach to that particular customer and will convince him to buy a policy. But this module, the automatic decision making module, when we construct, we should make a decision that which particular attribute has a great impact for constructing the decision tree. We can have this age factor on the second level and some other attribute at the first level, because the levels may, if the level differs, we'll say that students, whether the students can be placed at the level of age, and age can be placed on some other location, so that the decision making is definitely going to change, and it may create a different impact on decision making. So we should have a proper policy to decide which attribute has to be selected. So for doing this particular thing, we need to understand how does it work, how does this decision tree work. This decision tree is a top-down recursive divide and conquer kind of algorithm, but basically this is greedy algorithm because it used to select the particular attribute which provides you the best quality output. The attributes are categorical, and these particular algorithms are also having recursively defined. Then test attributes are selected on the basis of historic and statistical measure. It means the information gain. If in short, we will say that out of multiple attributes, we have to choose the attribute which is going to provide the best output for making a decision tree, or the location where the particular attribute will be used. So our task is to select a best attribute which will provide improve the performance of the algorithm. So out of multiple attributes, we are supposed to select one of the many. Let's assume that the attribute is used to be based on a particular entity, that is known as information gain. If an attribute has a larger information gain, then that particular attribute should be selected and used first in the higher level of the tree. Information gain of the attribute is lesser, then it should be placed on the lower level of the tree. Then only the tree will perform, or the algorithm will perform better. So this can be done. Let's say that let P be the probability that an attribute tuple in D means number of attributes, how many transactions it has, what is a total number of count of the tuples available in the data set, belongs to a class Ci. There are multiple classes available depending on the particular data set, and the total number of transaction and the how many number of times the class or the attribute is exist in that particular the tuples. Expected information, it's known as entropy. So this is something like a total number of attribute tuples available in this particular data set has to be calculated. The information needed after using A to split D into V partitions to classify D. D is, again, already I said, total number of sets, but sometimes we have to classify the attribute into multiple of them, multiple classes, so that the further decision making will be more easier. And because this attribute is sometimes has more complex, and that has to be classified in or separated in number of classes, and that is entropy, that is expected information for attribute A, for that particular attribute. So information gain is defined by subtracting the information, the entropy or expected information of a main attribute on which we are going to classify, and the another attribute in this particular data set. This is known as gain of a particular attribute. If a gain is larger, already I said, the attribute has to be used first. This is the example. So in this example, we can understand how the formulas are used for generating the information gain of the attributes. So first is we are going to work on the decision making attribute, that is Bayes computer. So this is the table. So this table we have already seen, and in this Bayes computer attribute we have different information, and depending on this information we have made two classes. One is Bayes computer and the person who has a probability that they do not buy a computer with a no tag. So class P and class N are generated. Out of these 14 transactions, we have 14 transactions, and out of 14, 9 people has a probability that they will buy a computer and 5 who do not buy a computer. So we use the formula which has already seen. 14 is a total transaction. Out of 14 we have 9 who can buy a computer and 5 who do not buy a computer out of 14, and 0.940 after calculating this will get a entropy or total information for the attribute says Bayes computer. But this is decision making attribute, and with this decision making attribute we are supposed to use these particular attributes for generating a tree. We have to check which particular attribute can be used first, so that the decision making of the tree will be more efficient. So let's start from a first attribute, that is age. So this age attribute has multiple entries, and let's make a class with the available information. So age is having we can classify it in 3 different classes. One is the age which is having less than or equal to 30, and the edge which is in between 31 to 40 and the edge which is greater than 40. So three different classes are made. So out of these three different classes, in these particular transaction, two people will say that those are going to buy a computer whose age is less than 30, and three are there who are not going to buy a computer. The same for here, for the age 31 to 40, 4 will buy a computer and 0 is no person is there who is not going to buy a computer. So for the age greater than 40, 3 people will buy a probability that 3 people will buy a computer and 2 will not. So we will apply the information with that particular class to generate I, because out of this we are going to check that how many are going to buy a computer and not. So 2 will buy a computer and 3 will not. So I could 2 plus 3 5. Out of 14 we have 5 possibilities for the age which is less than or equal to 30. Then for the age 30 to 40, 4 out of 40 will be there in the group 31 to 40 age group, and so that information gain for 4 and 0 classes will be generated. Same for the age 41 more than 40, so we have 3 and 2, so 3 for yes and 2 for no, and this is how once we calculate we'll get a total information gain for the attribute age is 0.694. So we have to use this information for the age, and the main attribute is here, so 0.940. so this is 0.940 and this is for the age, there is 0.694. Once we subtract, we'll get a information gain for the attribute age, and that is 0.246. The same method we are supposed to apply for all the attributes like income, student, and all credit rating. So when we apply this method on all the attributes, we'll get the information gain for income, this is 0.029, and for the students 0.151, and for credit rating that is 0.048. So out of these 1, 2, 3, 4, we know that the 0.246 has a higher information gain, and this has to be used first, and that is why we should also check whether the tree for the model constructed is either overfitting or the underfitting. So actually the overfitting problem generates multiple times, and because of that the tree will be very huge, and we need to make it small so that the algorithm will be more easier to work and faster in speed. So that is why once before we constructing the tree, we should check that the branches should not increase. So that is why we have to check the attributes and try to avoid the noise and outliers of the data. so that the unknown, it will not create an unknown entity where we are not going to work as a classifier. So those are known as noise or outliers. So poor accuracy for unseen samples may sometimes this can also be seen in the problem of overfitting. So two approaches to avoid the overfitting. First is pre-pruning and the second is post-pruning. In pre-pruning method, the all the tree construction, whenever we find a problem, this is during the construction development of a tree, this happens. And second is once we have already constructed a tree, then try to remove the branches so that it will be more easier to make a smaller tree. Then enhancement to a basic decision tree induction. We have to follow few important facts while designing a tree. Allow the continuous valued attributes. So dynamically we have to define, or we have to separate the attributes for the continuous valued attributes in such a way that the classes has to be constructed very properly and very accurate. Handle the missing attributes. Sometimes so we will be having some missing things, so assign some common factor, some common value, so that this missing place will be filled with some meaningful data, and classification of the attribute will be more easier. The attribute construction, create a new attribute based on the existing ones are separately represented. So whenever we are having the attributes, that should be fragmented, and the replicas need to be removed so that the classes will be constructed well, and it will get a very proper decision tree module. Then we have to make the proper rules for the classification. So these rules will be made out of the when we construct a very proper module, then the decision making attributes can be used as rules. So this particular example is like something like if and then feature facility is always there for us for constructing the rule. For example, here if age is equal to youth and student is equal to yes, then computer buy is equal to yes. This is a very simple example with which we can understand how the rules can be defined for constructing, making a decision for the data set. So, but whenever we construct the rule, then we are supposed to check the features or the characteristic of the rule. This is the cover and correct. So n covers is tuples covered by R. R is the rule, how many tuples are covered under this particular rule. So correct, so R means this rule, how many correctly classified examples are there. So it is going to check the accuracy further, how many number of covers, out of that how many are correct. That is nothing but accuracy of our module, and this is definitely going to allow us to create a very good decision rule, so that can be used further very properly. So whenever we construct multiple rules, then we should check that the rules should not have a conflict within, so that multiple rules are having the same attribute and we trigger all of them, then it may create a conflict, and the module will not work as per the expectation. So this care has to be taken while implementing and executing the module once it a decision making tools. So this is a decision making tree algorithm, and some decision making rules what we have studied today. So we'll meet in the next lecture. Thank you.